solving for L, and L is being sandwiched by 1,200 with an estimate of negative 0.5. I have to divide both sides by 1,200, 1,200 to get rid of the coefficient. So I'm going to have L exponent negative 0.5 equals what? 100 over 1,200, which will give me 1 over 12. Alright. What's now L negative 0.5 equals what? 1 over 12. Our main job is to make L the subject. Before we make L the subject, let's look at some few things we have to do. Now, when I have a value like, when I say y, x squared equals 1, and I have to make x the subject, okay, let me write it here for us to see it visibly. X squared equals y, and I have to make x the subject, meaning I have to get rid of the exponent. Some people could say, let's square root both sides, which is easier. I'm going to have root of y, right? But root of y is the same as saying y exponent half. So instead of going this long route or this long process, I can say x squared is equal to y. Now, this 2 is a whole number exponent. 2 over 1 is a whole number, it's a fraction exponent or fractional exponent. So this 2, every number sign can know is over 1. So 2 is over 1, 3 is over 1, making 3. So this 2 is over 1. When I switch this 2 to the right, that is the process as an exponent to the right, it's going to be y exponent. Now look at how it's 2 over 1. 1 will come up to the numerator, 2 goes down to the denominator. Which is the same as the long process I used. So that's basically what we're doing. Now, if I'm having x squared, x minus exponent negative 2 equals y, and I want to make x the subject, is a similar concept. Here, 2 is divided by 1, y is 2 divided by 1. So when I'm going to have x equals, assuming I'm moving the negative first. So when I move the negative first, I'm going to have 2 over 1. The negative is going. When negative crosses the sign, it will swap or transpose 1 and y. So we're going to have y coming up, y, 1 coming up, y going down. It is as a result of the negative exponent. I'm transposing the denominator and numerator on the other side. Now, having done that, the exponent 2 must also move away. So I'm going to have x equals 1 over y, all in a bracket. Then the exponent 2 over 1 will then become a half already, you know. When the exponent crosses, the denominator comes up, the numerator goes down. That is what we are trying to look at here. So, with this example out of the way, let us go back to our way. L exponent negative 0.5 equals 1 over 12. So L will be equal to, let me move the negative first, which will give me 12 over 1. Then, remember the 0.5 is over 1. So I'm going to have L equals 12 over 1, exponent 1 over 0.5. This is what I'm going to have, which is the same as L equals 12, exponent 1, 0.5. So let's compute it and see what this value gives us. So eventually we're going to have our L to be what? 144. Alright? So it says, what is the profit fundamental level of output and labor usage? This is the profit fundamental level of labor usage. Okay. We haven't gone through all yet. We have to now find the output. So substitute L equals 144 into the production function kill. So what is the kill function? The kill, we are not going to use the one with the K and L. We can use the one with the K and L, we get the same outcome. As long as we use the Q equals what? 6L 0.5. When we plug it into the, let's use both sides and see, just choose one. So Q equals what? 2K 0.5, L 0.5. Here we say, where L equals 144, so Q equals 6, 144, 0.5. And here we know K to be 9 from the original question, and L equals what? 144. So Q equals 2, 9, 0.5. Then 144, 0.5. So please choose one. Don't use both. I'm using both as a scenario for us to understand the concept. So here, since I have K already, I can pick this and instead of L. Here I already have L, I only set the L. So with this first, I'm going to have 6 divided by 144 exponent 0.5. With this league, here we call 72. Then I'm going to have 2 into bracket 9, 0, 2 into bracket 9, 2 into bracket 9, 0.5, then 144 into bracket 0.5. Right, so you can see both give us the same outcome. Therefore, the recommendation is you choose only one for your calculation. Either use this or that. You get the same absolute result. So we are through with question 2. Now you have to write a narration is marked. Therefore, the profit maximizing level of output is 72 units and the labor usage is 144 units. That's what we do. So actually states the full narration in addition to calculation for the full mark. 2. Question number 3, sorry. Now, what is your maximum profit resulting from your answer in IR? So we are asked to find the maximum profit. So what is the profit here? Profit in economics is equal to what? Total revenue minus total cost. Do you know the value for total revenue? No. Do you know the value for total cost? No. You have to solve each of them separately and plug them back into the profit function and find a profit. I'm using the pi to represent profit here. Okay? I'm using the pi. So let's first find total revenue. What is the formula for total revenue? Price times quantity. We good? And from the question, we know that the price value is, from the question say, when price equals, that's it, how much the shares were sold, $400, and the output we just calculated is what? 72. So TR equals what? 400 times 72, which is TR equals 400 times 72. It's 28,800 cedis. So that's our total revenue. But having gotten the value for total revenue, have you gotten the value for total cost? No. So total cost, what will be the formula? Remember, we want to know the per unit cost of capital times the unit of capital plus the per unit cost of labor times the unit of labor. In this question, I'm using the R and W because that is what the question gave. Other sense, they might say price of labor, cost of labor, or cost of capital, price of capital. So total cost will be equal to, remember, where we have, where R equals, R was, okay, where we weren't given any specific value for R, but we're given where RK equals what? 9,000. Now, RK is the total cost of capital. Total amount spent on capital was what? 9,000. I will. Then we will go for W to be what? Wage was paid at 100. We good. Wage was paid at 100. And then we know our labor unit to be what? 144. So total cost will be equal to 9,000 plus what is the wage? 100 times what? 144. So total cost will be equal to, add everything together. If you wish to bring them down, fine. That is write this and add this together, that's fine. But I'm adding everything together here. So 9,000 plus 100 times what? 144. So I'm going to add it together. 23,400. So we've gotten our total cost, total revenue. The profits, having gotten our total revenue and our total costs, what is the profits? Our profit function, because what is total revenue? 28,800, and our total cost is what? 23,400. So what is the profit function? 5,000. So the question says, what is your maximum profit resulted from your answer in II above? Therefore, the maximum profit is 5,400. I think it's in dollars. It's in dollars actually. So we should take it in dollars. All right. Now let's go to IV. If shareholders have raised a total of 30,000 for the firm to spend on both capital and labor, making it possible to vary both capital and labor, what unit of capital and labor should the firm employ to minimize its costs, assuming the per unit cost of capital and labor in the production function remain the same? I chose this specific question because it's two ways. Now, the first one you saw is already short term, but before, the question here is also asking us to find the units of capital and labor the firm should employ to minimize its costs, assuming the per unit cost of capital and labor in the production function remain the same. So, another concept. How do you avoid this? You must ask yourself, in which period is the production is the firm operating? In the long run or short run? Now, this question is the long run. Why? Because of these very key words. It says that making it possible to vary both capital and labor. Vary is the verb, variable is the adjective. So here in the long run, we vary both labor and capital. Again, the question says, assuming what unit of capital and labor should the firm employ? What units? We're not giving capital units in this IV, right? So long as you're going to calculate for the unit of capital and labor, it's in the long run. So this is a long run question. So let's start with, again, the values, the IV. Okay, we're giving total cost to be $30,000. That's the total cost, $30,000, which is the IV. Okay, and since you are asked to find that making it possible to vary both capital and labor is in the long run. And remember what you learned about the optimal level of our long run production. So in the long run, at minimum costs, remember we only minimize costs, marginal rate of technical substitution equals marginal product of labor over marginal product of capital equals what? Wage over rates. Now, when we say marginal rate of technical substitution, it means that the firm is going to change the combination of its inputs, that is the labor and capital, which helps it obtain its optimal levels, right? By a certain rate, it's going to technically, like expertly, change its labor units and capital units to obtain optimal production. And there is a rate at which it can be changed, 20%, 30%, that's the marginal rates, okay? So you have to look at the change in the NPL and the change in the capital to give us an optimal level. Alright, so first, what we do is, we know our W and our R, where our W equals what? Our weight is 100. Our R, which is our cost of capital, wasn't given from the question. So we don't know our R. So we have to go and set for our R. How do we find our R? Remember what I wrote here. Total cost spent on capital was 9,000. So our R and K equals 9,000. And remember, our R and K equals 9,000, where our K was what? 9. So we can find our R. So we will say R times 9 equals what? 9,000. If I go side by 9 by 9, I'm going to have to go 1,000. So our R equals 1,000. So we find our R. Then we ask ourselves, now that we've got our W and our R, what about the NPL and NPK? We have to go and solve for them later on and bring them in. Now we will take out the equals NPL over what? NPK was what? Wage times R. Now we know our NPL over NPK because what is our wage? Our wage is $100. Our rate is what? 1,000. So we have to find our NPL separately, find our NPK separately, plug them back into the function. Where NPL equals what? DQ DL, right? Then our NPK equals what? dq/dk. So all that is trying to tell us to do is, remember what the question said. It says that assuming that the unit cost of capital and labor in the production function remain the same. They remain the same. So we are not going to change the original equation. We still go back to our original equation, which is Q equals 2K 0.5, L 0.5. All this remain the same. So dq dl means visit equation Q, differentiate with respect to what? L. When we are differentiating with respect to L, I have to maintain my K exponent 0.5. Let me use a brief example before we continue. When I have Z equals 5x plus 3m plus 9. Let us have 5x squared. I do 5x squared. And I differentiate dz with respect to x. Meaning I'm only going to concentrate on x to differentiate. Is there x here? The first term. This is the first, this is the second term. Is there x in the second term? Yes. So 2 times 5 is what? 10. Then x. 2 minus 1 exponent 1. Is there x here? No, that will be 0. Is there x there? No, that will be 0. That is my derivative. Now, another scenario is I have z equals, let's say, 2m plus 5xm squared or 5mx cubed. Then this is squared. So I have to differentiate with respect to x. Is there x in the second term? No. The third term, yeah, there is an x. But though there is an x, unlike the first example I did, or the first illustration, I'll maintain my n squared because I'm not differentiating my n squared. And I'll go after the x, which I'm differentiating. And don't forget, this square root of 5 is for both x and m. It's not only for x, it's for x and m. Therefore, my 3 exponents for x will multiply the x, the 5, which will give me 15. Then my x will be repeated. I'll subtract 1 from the 3, which will give me 2. This is my derivative or differential. So when it comes to differentiating a variable, which is multiplied by another variable, the other variable which is not being differentiated is not affected. It's maintained in its original state. But the very variable for differentiation is affected. Alright, so that's the same scenario I'm going to do here. So we have our quantity, which is from the original question, and we are differentiating with respect to L. Now, here, we go back into this is the K, differential equation K with respect to L. So we don't touch the K, like the example I did. So we retain our K 0.5, but the L will change because I'm differentiating with respect to L. So 0.5 times 2, which gives me 1. 0.5 times 2, which gives me 1. So that is 1. Let me put a 1 here. Then we will have, let me put the 1 here. Then we'll have our L. We subtract 1 from the 0.5 because we are differentiating L. Therefore, the exponent will be affected. So negative 0.5. We good? Alright. Then dq dk, which is the second denominator. dq dk, we are different dq dk. The same function, only k will be differentiated, L will not be. So I maintain my L 0.5. But they say 0.5 of k exponent multiplied by 2 is 1. Then my k will be subtracted 1 from the 0.5 to be negative 0.5. That's what we have here. Eventually, I have my NPL values, NPK values. Therefore, I'll say that I'm setting my LPL with a value, with a function. So k 0.5, L then 0.5 was 1 times k, or 1 times the whole of that, giving the same thing. Over there in the denominator to be the NPK, I'm going to have k negative 0.5 and L 0.5 equals 100 over 1000. So let me cancel these zeros away. I'm going to have 1 over 10. Alright. So before we continue with this also, so eventually I'm having k 0.5, L negative 0.5, all over k negative 0.5, L 0.5 equals 1 over 10. That is what my states now. So if you have any questions, you can drop it in the comment section. We will see how to help you understand it better. Right? We have our email also there. You may email us and will help you with the solutions or help you to understand better. Alright, so in this state, let me use a very simple way to analyze this. I can give a deeper interpretation, but let me use a very simple way. I'll still maintain my k 0.5, which is in the exponent, but my L, which is the exponent, is negative. When I drop it to the denominator, it becomes positive. So let me drop my L first. My L becomes what? Positive. This very L, which is negative exponent, becomes positive exponent. Then the k, which is the denominator, is negative, also goes up there and tends to be positive. So the k goes up again, and from the denominator tends to be what? Positive. Then my L, which is the k in the negative, in the denominator, is still positive, so I keep it. Right? Because what? 1/10. Now, what is the concept of indices? When I have 2/a³, indices, when I have a³, a is the base and 3 is the exponent. So, I multiply the whole number by 2. I'm changing this into the inverse form. So 2 multiplied by a gives me 2a. Then this dash here becomes, the over here becomes the exponent negative, and this 3. So this 2a exponent negative 3 is the inverse form of 2 into bracket 2/a exponent 3. We good? That's it. Now, another scenario is when I'm having, let's say 1/b squared. 1 times the base b gives me b. The over gives my exponent, then the 2. So this is the inverse form. When I'm having 4/c negative 3, I'm having 4 times c, which gives me 4c. Then the over becomes the exponent. Then the negative exponent also will come with the 3. Therefore, I'll end up having 4c exponent 3. Because ordinarily, we would say this 4c/3 is a numerator and 1 is a denominator. So that is how come we're able to swap all these together to get positive exponents to work with. So quickly, in indices also, when I'm having a squared times a³, I have to bring all the base together into 1 and add the exponent. So I'm going to have a exponent 5. The same way. Therefore, since k and k are the same bases, I'll keep the k, add the 0.5 to the 0.5, then the L2, add the 0.5 to the 0.5, because they are all multiplying, equals 1/10. All this gives me k over L equals 1/10. Then what do? We cross multiply. We cross multiply. So k multiplies 10, which is 10k. L multiplies what? L multiplies 10 is what? L multiplies 1, which is L. Therefore, we know about L equals what? 10k. This becomes our equation 1. Why equation 1? Because we have to go and find an equation possessing both variables of L and k before we can solve. But the question here is saying that assuming the per unit cost of capital and labor and the production function remain the same. So which other function can we obtain? Which has k and L, which we are going to solve for, and also has another value. If we go and choose the output function or production function, we are going to be mistaken because the production function doesn't have any value for Q, although it has K and L. So it will be mistaken. But the clue is this. The question gave us a total of what? 30,000. So just like previously, we will choose the TC function, which gives us a what? An RK plus an WL. An RK plus a WL. Here, alright, let me do this way. Here, the person in this state wage or rent. Generally use unit cost of capital. So cost of capital is what? Total cost will be equal to, let's say, RW, RK plus what? WL. Where cost of capital is what? PKK plus what? PLL. Alright? So what is our value for total cost? 30,000. What is our price? It says, assuming the unit cost of capital. What is the unit cost of capital? What is our PK? Which is our R, which is what? 1,000. So 1,000K plus, what is the price of labor? Which is our wage, which is $100. So $100 of L. It says, assuming the per unit cost of capital and labor in the production function remain the same. So we are just bringing them again as we knew them before. They all remain the same. The RW and PPL, they all remain the same. Therefore, we've gotten a value or a function with an K and L and another constant. This becomes an equation 2. I believe at the end of the session, you'll be able to comprehend both the application of the short run and long run, but you need to solve more questions, extra questions, okay? And our email is below. You may send us a question and don't forget to subscribe to our channel. All right, let's proceed. I've gotten L equals what? 10K equals 1 and 30,000 equals what? 1,000K plus what? 100L equation 2. We now solve substitutively. Let me say substitute L equals what? 10K into what? Equation 2. So 30,000 equals 1,000K plus 100, where L is what? 10K. So 1,000K plus 1,000K equals what? 30,000. 30,000 equals what? 2,000K. Divide both sides by 30,000. We will have 2,000 or what? 2,000. 1, 2, 3, 1, 2, 3. 1, 2, 3, 1, 2, 3. 2, 1, 2, 15. So we're going to have 15 equals what? K. Or K equals 15. Substitute. Having found our K, we go and substitute K equals 15 into equation 1. What is equation 1? L equals 10K. So L, where K is what? 15. L equals what? 115. So in the long run, as we could see from the question, that in the long run, both labor and capital are what? Variable. The first short run production, we're having K to be another figure. K was given as 9. But in the long run, it has been changed to 15. And labor has also increased from 144 to 250 in the long run. So, what unit of capital and labor should the firm employ to minimize its costs? Having gotten my K and my L, so therefore, the firm should employ, right, 15 units of capital, 15 units of what? Capital, and what? 150 units of labor to minimize costs. As I said, when it was in the short run question, all right, capital was 9 units, labor was 144. But in the long run, when the firm was going to make choices, capital now becomes 15, labor now becomes 150. So in the long run, capital and labor are variable. By the short run, capital is fixed. Right, that brings us to the end of our tutorial session this afternoon. Thank you for watching. Subscribe, send your comments and your comments or email us with your questions and we'll respond to you. Thank you very much.